our dynamic talk today. So today we have streaming from our office in Chisinau, and here I am a moderator from online part to connect you who is online and who is offline in our office. Thank you for visiting, even how you join us. So today we have our speakers who are ready to talk about their interesting topic. But before it, I wanted to share with you some information that is crucial to participating. So during the talk, please, if you are online, please be muted so you will not interrupt our speakers. And about the questions, as usual, so to ask a question, you just need to write it in the chat if you are online, or after the talk during the Q&A session, you can unmute yourself and the speaker will hear you and answer your question. If you're offline, you just ask a question. That's simple. So I think that's it. So firstly, I want to ask our engineering manager of Moldova and Romania to tell something about our company and why we are talking today about this topic. Denise, please.
Thank you, Lavina, for the great introduction. Dear colleagues, good afternoon. Welcome, everybody. I am excited to host this event. I'm excited to welcome you to Grid Dynamics. I am Dennis, engineering manager for Moldova and Romania, former DevOps, a topic which is interesting for me as well. Thanks, guys, for preparing that. Before diving into techie stuff, let me have a small introduction about what Grid Dynamics is. So we are basically a leading provider in various technologies and consulting areas. And we are serving the top 1,000 Fortune clients. For those who are familiar with Fortune 1000 very well, for those who don't, go Google. It's basically top 1,000 kind of wealthy enterprises. We've been established since 2006, and we've been growing constantly. And right now, if you have a look at the map, you would notice that we've kind of spread it across the world and got the presence in over 18 countries. We continue spreading little by little, and European, one of the most strongest offices are Moldova, Romania, Poland, Serbia, and Armenia. Of course, others are getting traction as well, but this happens gradually. We are slightly over 4,000 engineers already, with a goal to become 6,000 by the same time next year. A very brief intro onto the verticals that we serve and a bunch of names that we work with. I won't be reading, just have a look yourself. But we basically power ourselves by creating 4 pillars. As you notice, that's media, manufacturing, health, and insurance, as well as retail and brands. Now, slightly a bit more into the engineering stuff, exactly how we do that, how this thing works. It was conceived to be built upon strong disciplines. Those were not strong at the very beginning, but those became strong as we evolved, as we got more experience, more clients, more lessons that we learned across developing stuff. So disciplines is what you see at the bottom layer. On top of that, artificial intelligence. Of course, it's a very buzzword, but we've been within the AI area since quite a while, implementing various stuff, various features for different clients. And all these things actually materialize as 4 pillars, one of which we cover today. That's basically cloud stuff, Mac applications, data. We strongly believe in data, so data engineering keeps getting more and more focused. We are growing the practice across several regions, but also specifically here in Moldova. Analytics as well, and also experience. Experience is basically the interaction that user gets when interacting with the presentation layers, basically web apps, mobile apps. I hope I created a small intrigue. So if you want a deeper understanding, if you want to dive deeper, I encourage you to visit carriers.predynamics.com to find out what's more in there for you. And assuming there are no questions, I am happy to pass the word to Alexei and Cristian. Guys, on to you.
Hi, can you hear me?
Yes.
Okay. Let us introduce ourselves firstly. My name is Alexei Murinet. I am senior developer in Grid Dynamics with experience of building global distributed and resilient application. Also, I am holder of 2 AWS certifications.
Hi everyone, I am Cristian. I am also software developer in Grid Dynamics. Also I have 2 certifications as Alexei. So now I think we can start and our presentation, our summary.
Yeah, we will show agenda of our presentation. First of all, we will speak about resiliency in AWS, when we will provide options to create resilient microservices, when we will test our architecture and provide a conclusion after our testing. So let's begin. What is resiliency? Resiliency is ability of a system to operate after some disasters or failures and recover from them. So it will mitigate some potential revenue or reputational damage. Maybe one of you also struggle with building resilient architecture on AWS or our cloud providers. Silence. Okay, let's continue, because this problem is not only by some small companies. Even big companies as Google has a resiliency problem. For example, in 2020, we have only 45 minutes outage, but it takes down Google services as Google Drive, YouTube, Calendar, Google Home, and we potentially lost 1.7 million because their system notification wasn't able to auto-scale in this situation.
Another famous company that we all know, it is Facebook or Meta now. And as we know, it has more than 3 billion users. In 2021, it has an outage for around 6 hours, and it cost 60 million disadvantages, and the revenue was lost. This was because of the error in configuration, because some routers cannot route to each other, and all the data centers were blocked from each other. It was a very happy situation that in some offices, workers couldn't enter in the office because they just cannot authorize themselves.
Okay, next is even Amazon has a resiliency problem. We created their own Prime Day, which is kind of Black Friday. And in 2018, we underestimate the popularity of this event, and we are not able to handle traffic within 15 minutes. And on estimation, we lost $1.2 million in this outage. So I hope it will show how resiliency is important, and we can dive deep how to realize it in AWS. Let's start from AWS global infrastructure. As you can see in the picture, AWS consists of regions. Each regions also have minimum free availability zone. Its availability zone is one or more discrete data centers, fully isolated with network power. So if to build a global infrastructure, we can deploy our application in different availability zones. And if one availability zone will fail, other availability zone will continue to functionate. Another very important terms in case of resiliency is RTO and RPO. RTO is recovery time objective, is the maximum acceptable delay between the interruption of service and restoration of service. And RPO, recovery point objective, is the maximum acceptable amount of time since the last data recovery point. So we can see here how it works in diagram. And next is options in AWS. AWS offers us 4 options. We are sorted from most the cheapest one to most expensive one. First is backup and restore. When you have only some, when you will deploy your application only after some disaster will happen, and it will take hours to recreate your application. Second is pilot light. Pilot light is when you have only a critical part of application running, and when disaster happens, you will scale it, and it will take tens of minutes. Next is warm standby. When you have a small version of application always running on your AWS, and when disaster happens, you just scale it up, and it takes some minutes. And the most powerful one is multi-site active-active. When you have a fully managed application running on AWS, and when some disaster happen, you just point to a second version of application. It is near real time. AWS, for example, also offers multi-master databases like Aurora, which can be multi-master for read and writes. Okay, Cristian will continue about resilient microservice architecture.
So let's begin with what are microservices. So microservices is a special strategy, is a special architecture that unbound all our services from each other. With this approach, we can have a very productive and most important resilient pattern, and we can use it in many types. So today we will talk about how we can and what services we can use to make such architecture in AWS. So first of all, let's begin with a small overview of services that we will use in our system. So first of all, it is RDS, that is a relational database system, that we will use for databases, S3 for file storage, EC2 for compute instances, CloudWatch for monitoring and alerting, SQS or simple queue service for unbound and sending messages from services between them. Simple notification service to send some alerts and messages, for example, in email. Also Lambda for functions and Route 53 for DNS. So about all of these services and how they can improve your resiliency, we will talk right now. So let's begin. First of all, let's talk about what are compute instances. So in AWS, we have EC2, that is a very standard services in AWS, and it offers now for us compute instances that we can use. Also, AWS, it is not just a server that you can host. It also provides some very important services like auto-scaling, groups, and load balancer. Load balancer we will use to route traffic between different instances to have an equal and don't have bottlenecks in our traffic. And auto-scaling is special services that will increase our amount of instances after our special criteria. Second very important part is AMI. As we talked before, we have auto-scaling, and that means that all our instance scale up or scale out or scale in. So when we increase or decrease our instances, it is programmatically. That's why we need to have our template from which we can, first of all, increase the time of our launch of our instances. Also, we can have special scripts or special systems that we can install prevently and don't have errors when we have some custom applications. For example, for Java, we need to use GTK, Gradle, Maven, and so on. Also, our such things we can install in Amis and use after that on creating new instances. So it is like an image for EC2. Next, we will talk about CloudWatch. So CloudWatch is a service for monitoring and logging our activity in our EC2 instances. So for example, we have a lot of metrics that we can check in our CloudWatch, for example, CPU usage, memory usage, RAM usage, and so on. And with these metrics, we can after that create alert that we will use to increase or decrease our capacity in autoscaling. So this is a very important service. Next one is S3. This is storage. So this is bucket storage. Why we are using S3? Because it is very highly available. It has 99.999% of availability, so it is very available. It is also very fast and relatively cheap. Main advantage is not only availability, but also that we can use this bucket in a lot of instances simultaneously, and we won't have problems with using it. And it also has a very simple API to use, and that's why we use S3. Next one is Lambda. So about Lambda, Lambda is a serverless service. What does it mean, serverless, for somebody who don't know? That means that we don't manage our servers. We don't manage configuration of it. Everything of it, it is by AWS. We just provide our code, and AWS make all work for us. So Lambda, it is a very good service for small tasks, for tasks that we can trigger and we don't need to manage. And that's why we also use in some of our parts Lambda as well. Next one. Also, this is more for testing. This is about X-Ray. So X-Ray is a special service in AWS that provides us monitoring of tracing testing. So as you see in the image, we can see how all our services are connected, what is the path and the parts of the request. About X-Ray, we will talk a little bit later in more in testing section. Route 53. Route 53 is a DNS, so domain naming service. Using Route 53, we can register our domains. And also Route 53 has some very important features like routing policies. Especially for resiliency, we need to use a failover policy, but using health checking of the instances or elastic load balancers to check health and to route from unhealthy to healthy instances. In this way, even we will, for example, lose one availability zone or one region, all our traffic will be redirected to another region and another availability zone, but it is still alive. That's why we need to use failover. As mandatory, we need to have a health check enabled for our EC2. So this is mandatory if we want to use these routing policies. Next one, we will talk about RDS, and for us, it is more important, it is multi-AZ configuration. So RDS, it is a service that we can use to host different types of databases, like Postgres, Oracle, MySQL, MariaDB, and so on. So almost every SQL database. And it has two types of configuration that somebody can be confused. So first of all, it is multi-AZ, and this is used for resiliency. So we have always a copy of our database in another availability zone that has a sync replication, so a very small latency in replication. This guarantees us to have, in case of failover, we always will have second database that we can use. So this is very important for resiliency. If we want to decrease our bottleneck in reads, we can use another configuration. It is read replica that we can use to point to another only read database and to use it just for reading and to decrease the main database with reading operations. So multi-AZ we use for resiliency to have copy of our database, read replicas to have read the database and to decrease our bottleneck. Next one. We will talk about messaging systems and the messaging services. First of all, it is SQS. It is a fully managed service by AWS. It is a service that provides us queues. So it is available in AWS. So AWS manages it, and we don't need to think about resiliency. It is always resilient. So what does this service provide? It provides queues, it provides dead letter queues, it provides pattern like try, retry, and in this way we can safely use it to communicate between services in a synchronous way. Also, SQS have such a feature like SQS alerts. For example, we can use SQS and to check one metric, for example, a number of messages in queue that are not consumed. For example, if you have more than 100 messages in queue that are not consumed, we can increase our instances in autoscaling. So that means that when in Cloud Alarm, we will have an alert, it will trigger our autoscaling, and it will increase our number of instances, so we can manage our load in the best way possible. And the last service, it is SNS. So this is service that provides AWS to send different messages. It is its pattern, it's publish subscriber. So we have our publisher. It can be EC2, Lambda, another service, and it sends all our messages to SNS topic. And after that, we can have a lot of subscribers. It can be some services like Lambda, another SQS, or Kinesis, or EC2. And also we can have ability to send other messages like email, SMS, also using this SNS service. So these are the services that we used. And more about architecture, we'll talk Alexei.
Thank you, Cristian. Yeah, let's go to practical part to implement what we said in the practice. So we have an e-commerce application with product service, order service, notification service, and delivery service. For example, user goes to our shop, select some products, it will check availability. When it place order, it send message to SQS queue. When order service will consume our messages. And when by find-out pattern, it will send our order information to notification service and to delivery service. So let's see how it will look like on AWS perspective. We will have route 53 to be a DNS server elastic load balancer. First, we will have autoscaling group for product autoscaling, where will be available in different availability zones. So if some problem will happen, it will automatically switch to second availability zone. When it publish message to SQS queue, which will be consumed by order autoscaling group, Also, as Cristian mentioned, we will have CloudWatch alarm, and it will monitor our SQS queue. If we have a lot of messages, we will add some capacity for our auto-scaling group. And when it will publish message to SNS topic, which will be listened by Lambda, for example, to generate some invoice, and will send notification to our user. Also, we have databases which will deploy it in multi-AZ configuration to have a primary database and standby, which will automatically be changed if failover happen. Also, we will have X-ray, which will monitor all our activities and maybe will help us to find some bottlenecks which need to add extra capacity or to change our architecture. We can go briefly by the code. So yeah, we have product service. It's a typical CRUD service, which have some endpoints to get products and, for example, place order, which will sort our order and will send message to SQS queue when we will go to order service. Yeah, we have API. Also, we have listener, which will listen for our product queue and will handle our order, save it in database, and send email and invoice notification to our SNS topic, which will be consumed by email and Lambda service. We can go directly in AWS to show how we created such an architecture. First of all, we have auto-scaling groups. Here we can see desired capacity, minimum capacity, maximum capacity of our service. We can show activity when our EC2 launches. Also, we have email notification when our EC2 terminated or launched. Yeah, we have both for all our services. We have different auto-scaling groups. Next, we have queues. One is product queue, where we will consume our messages. And the product queue, we have simple notification service. Here we have some topics. For example, for order email, we, as Cristian showed, we can have different subscriptions. And here we have subscription to email, subscription to SQS queue, and subscription to Lambda. Yeah, and we have Lambda, which will be triggered by SNS topic and will send our application to our invoice to S3 bucket. And also we can monitor our Lambda, see how it was produced by CloudWatch. Here we have some logs. Also, next in the test section, we will talk more exactly about testing in X-ray. Here we can also see in monitoring section some traces, how much takes the Lambda, was it successful or not. Let's try to trigger some endpoint, for example, to order 2 products for me. Yep. Yeah, we can see successful message. Also, here we can see that we have email, and if we go to S3 bucket, we can see what. Yeah, now we received an order invoice. Yeah, it's a brief overview. We will talk, our demo will test our application in next sections, but firstly, let us continue to discuss some other options to design microservices. Yeah, as Cristian mentioned, we use AMIs to make our application up and running, but also popular way to manage microservices is containerization, and AWS offers us a ECS service, which can be both of 2 types, of EC2 and Fargate type. And here you can see some advantages and disadvantages of both. when you use EC2, you have full control. You can flexibly scaling EC2, and you can decide, for example, your application can withstand with disruption. You can use spot instances, which is very cheap. But on our hand, we have Fargate, which is absolutely serverless, so we don't need to manage our architecture. It will be based on our CPU usage, and it will dynamically allocate resources and generate new power. Also, talking about resiliency, we need to mention some patterns. We are Java developers. We have a beautiful library, Resilience 4G. Here is listed some patterns which we will have brief overview. First is, I think, the most popular is circuit breaker, is inspired by real electrical circuit breaker, which automatically interrupts the flow if we have some damage. The same works in our circuit breaker pattern. We have three states: open, closed, and half open. And if if service starts to respond with fail response, we will change our circuit breaker state to open, and we'll provide fallback method, and will not send requests to this service, and we will not make cascade failures. When we have a closed principle and half open. When half open, we have some threshold, and we calculate successful requests, and if it's more than successful, we will close our circuit breaker. Next is retry pattern. It's when we have some errors, we will retry operation after some time. And yeah, it's not a good idea to use it with post or some changing operation. It's only with idempotent operations. So next is bulkhead. Bulkhead is a pattern when we isolate our system of failures. It's inspired by a ship where we have different sections. And if one section will break, the water will sink only in each section, and the whole ship will not sink because water will not spread through all the ship. So here in bulkhead patterns, we also have such ability. For example, even in AWS, we have two endpoints, one for post, second for get. And for example, post price is very resource consuming, and if this connection will break, we won't make our get price not working. So we make different connection from get and post and isolate from failures to our endpoints. Next is timeout patterns, when we have to set some timeout for operation, and if our operation will exceed time, we will automatically break it. So maybe we will also provide some fallback method, or we'll log an error or notify the user. Next is back pressure pattern, when we have fast publisher and slow consumer. We need to somehow make pressure for publisher. We do it in our application by using queues. Also, reactive Java is a good example for back pressure pattern. Next pattern is exponential backoff. It's similar with retry with some additional logic. I think it's good described here in the picture. We have our operation, and we will wait for 3 seconds, and next we will wait for 4.5 seconds. So we extend our time of waiting, and if third try was also failed, we will return fail result. Yeah, and Cristian can continue to testing part to test our application.
So I think we can begin with the notion what is stress testing. So stress testing is the special type of testing that is used to check the reliability performance under the pressure of our system. as one of the most interesting and really popular tool, it is Grafana K6. So what is Grafana K6? And it is a modern testing platform that we can use for all our web application. It has a lot of features. In our case, we will test it as an REST endpoints, so REST requests. So we can also use Grafana K6 as a cloud service, or we can install it just on our PC, as in our case. Also, Grafana K6 have ability to be installed using Docker image and Docker container. So if you don't want to install something on your computer, you can install it and you can manage it like a Docker container. So let's talk and see what Grafana K6, after we install, provide to us. So it provides us the ability to send special tests, special scripts, and to have a very expensive and very detailed stats of our performance of our system. In our case, we can see that scripts in Grafana K6 are in JavaScript. And as an example, you can see a small example of using Grafana to send post request using payload and how our request is established in terminal after that. More about this we will see in demo section. Also, another very important feature of Grafana K6 and why we can call it a stress framework, not just some testing. It is the ability to have such feature like rampage. So what does it mean? So we have an unstable number of users, of virtual users that are sending requests to our system. In this way, we can simulate such cases like some sales, some big overload of people that are requesting to our website, and how our website can manage this request, this load. For this, we have such options like reuse or virtual users that we can put it. We have iterations. For example, we can have step from 0 to 10 users. After that, we can have a stable step from 10 to 8 users. And after that, we can have a ramp down to 6 users, where we can manage our usual load. So in this way, we can simulate such load and we can see what is a real limit of our system. So I think we can, I think we can begin to our scripts. So let's first of all check how does it looks our scripts. So as I said, they are all in JavaScript, and this is our script. So we have our URL where we will send our REST request. So in this way, you can see that we have our payload. It is JSON, and we are sending to this email this product. All these products are selected randomly from this list. We put such small list to not overload the system, because when we will check with virtual users, you will see that we will have hundreds of requests in minutes. And we can see that we have our payload that we send. We have our parameters headers that you can also send. If you have some authorization parameters, you can also put it here. And after that, we can use post method from K6 HTTP. And after that, we can also use a check method from K6 to check our response. So in our case, we have our request post. We will put our URL, our payload, our headers. We will have a console log, and after that, we will check if we have successfully processed, if status is 200. Okay, I think we saw how the simplest scripts are in K6, and now we can run it. So for that, we can use, after you install it on macOS, you can install it very simply using brew, and just brew install K6. And after that, to run scripts, you put the folder where the scripts are located and run K6 run. And after that, you can see that we have the stats of our request. If we will see, we can have our log. So for this UI, we have status 200. We can see that only one request, it is 100. How many data we received, how many data we sent, and what is important for us, for example, a request duration. And in our case, it was 105 milliseconds. And failed, it is 0%. So we have just one iteration. So this is mean that we have only one request. And let's see our next script that we have a lot of iterations. So this was the simplest type of request. So just one. Now let's look to next one. Okay, one moment. Sorry for interruptions. Okay, I think we can check here. So if you see, we can see that we have almost all the same. In this way, we have a little changed payload to not send a lot of emails to Alexei and not to DDoS him. So in this way, we can see that we have first options that we watched. These are views. For us, it is just one users, and iterations. So iterations is how many requests does one user send. So for example, if you click a lot of requests, we can simulate it right now. So we can return to our script, and we put name iterations. And if we run, we can see that we have status for all our requests. It will take some time, and we can see at the end what are the results. So we can see that we have 21 kilobytes for 100 requests, and we can see what is the average time of request. So for the request, we have average time 85 milliseconds. We have minimal time 67 milliseconds. Median, so this means the most popular, so likely time of request is around 74 milliseconds. What is the slowest request? It is almost 1 second. And also we can see here that in the end we have 100 iteration despite first time. And now let's see what is the most interesting part. It is when we have so-called rampage. And what are the options here? So for rampage, we have so-called stages where we can set our duration. So how much time it will increase the number of users from 0 to our first target. After that, we can have a second stage to stay at some stable number, for example, from 10 to slowly decrease to 8. And after that, we have third stage. It is ramp down from 8 to 6 to simulate the decrease. And in this way, we can simulate how many requests and how stable is our system. So, of course, now we will have a small test because 10 users, I don't think that any system will decrease. But if you will have, for example, 1,000 users in simultaneously, you can see that almost any site any website can be down after such test. Okay, so let's go back to our terminal, and we will run our third script we use. And let's see how it is the changes. So if in the second type we had how many requests do we have till the end, now we have the counter of how many users do we have sending requests. So in our case, this is 10. So we have ramp up. So from 0 to 10 in 10 seconds. Now we have a stable part where we have the ramp down from 8 to 6. And now let's see how many requests. So in 30 seconds, we have 700 requests. And our stats are really well because we don't have any failed requests. We can see how our duration was changed during such load. So if in the second type, when one user sent 100 requests, we had 80 milliseconds as average. Now we have 300. And we see that minimal is almost the same. Median is a little bit slower in our case now. And the maximum, it is almost 9 seconds. So some requests were really slow. So this is mean that, but they didn't fail. This is the most important, that our system anyway was good for such pressure. So in this way, very easily, you can also check all of our systems and to see it. So the syntaxes, it is very easily, and you just need to use JavaScript. Now let's go back to our presentation and to talk about second tool that we used for testing. And this is X-ray. We also previously mentioned this tool, but now let's talk a little bit more about it because it is not the simplest type of tool. So X-ray, it is the debug and also testing tool that we can use to monitor traces. What does it mean, traces? This means all our request has many parts. For example, we have controller part, we have service part, or for example, or easily we have our service. After that, we have request to our database, and we can go back. And using X-ray, we can monitor every single segment and subsegment of this request. In this way, we can check where is the bottleneck of our system and to see it in using AWS. What do we need to use for this tool? So this tool, it is we can't use it just in AWS. So for this tool, we first of all need the X-ray SDK. It is implemented for a lot of languages like Java, .NET, Node.js, and so on. And we can install it using libraries. In our case, we used Maven, so our jar and SDKs. After that, we have so first element is SDK that we install in our application. The second one, it is a X-ray daemon. And this is a special tool that we need to install in our compute instance or in our container if you are using containers. So after you install this X-ray daemon, and you can send requests with all your data to X-ray API in AWS, and after that, you can monitor it in your console. Let's summarize. To implement X-ray, we first of all need SDK and to implement it. I will show you one way to implement this SDK. After that, you need to install, it is very simple installation on EC2, to install a daemon, and all the logs that your application are creating are sent to daemon, and after that to X-ray API. And from X-ray API, we can we can monitor it in X-ray console. So let's go back to our application and to see what is our SDK. Here we have a lot of libraries that we can use. For example, we can use X-ray to monitor HTTP, to monitor SDK, for first of all core and Spring, and also instrumentator to send all of these requests, all of these logs to Daemon. And after that, another important thing, it is logging. So we can see what pattern of logging do we need to use for X-ray and on what type. So for this is debug and error. And to configure this, we used filter, and we have a strategy that we have here. So this means that we have our order service. We will check all our endpoints or all our controller, and also we can have custom implementation using aspects. For this, we need to have our X-ray inspector that extends our abstract X-ray interceptor, and in the usual way, it is an aspect. So it search for this annotation that is provided from X-ray SDK, and when we put it, we can check and we can create our paths or subsegments and to check all our requests. And after that, we can also can give different names to our segments and subsegments, and we can monitor and manage it here. So this is the way. Now I think we can go back and to run script.js that will send one request, and we can go to AWS. So here we have AWS, and we can find our X-ray traces in CloudWatch service. And here we have X-ray traces. We can see traces, and here we can see that we have two traces. So if we one moment here. Yes, so didn't. Yeah, so sorry, we need to minimize. Zoom was interrupting us. So let's see what we have in our trace. So it how it looks usually. We have our services and we have our subsegments. So all of this, it represents one request. But you can see that even from this perspective, we have a lot of parts of a lot of services that are under the hood in this service. So this is an interesting request because it is asynchronously. So it begins when SQS listener catches our messages from queue. After that, we validate it and we save it in our database, in our repository. After we save it, because we put the flag true, we send it to email in our and the message to our SNS, and we can see how much time between every this step was. And after we send it to SNS, we can see that we triggered our Lambda, and after that we triggered our Lambda function. All of this we can also see here, where we can see our duration, our request, what was the response, how long it was for every step in our type. So we can see that for Lambda, we need almost 3 seconds. So initialization was 300 milliseconds, invocation was almost 3 seconds, and overhead, so the ending was 17 milliseconds. So in this way, we can see how the request is used. Also, we can have here the data. So we can see the resources, what we use, and also metadata here that we have, and we can see the raw data as well. One moment. So Yes, raw data. Here it is. So in this way, our application send our logs from SDK to Daemon, and after that it is sent to X-ray API. So you can see that we have our segment, our main segment, and after that we have our sub-segments and all of the data that we monitor. So what is the start time, what is the end time, what is the response, and all of this data, you can find it here. If we go back to, we can see and first, so we send a request from product service. So we saw now what was order service behavior, and now what is the product service. So we have our client that is sending requests in Postman, and after that we have our product application that has some layers like controller layer that we can check what was the duration for everyone, service layer, repository layer, so what is the how long it was the request to database. So you can see it was a very small request. It was 10 milliseconds. And after that, we can see that the most time it was sending a message to SQS. And in this way, we ended our request and we send it a response that request is send it to SQS, and you and our service can consume it from there. So I can think that now we can continue with what features in the next you can use and to develop this stack in the future. And Alexei will continue.
Yeah, also, I think one of the best tests to test our resilient architecture is chaotic test. Is done by running controlled experiments to mitigate some network outage, hardware failures, database issues, and see how our system will react on such circumstances. Netflix has awesome library to implement it. So if you are interested, you can try to use it. Also, in case of resiliency, I think it's important to also read about CloudFront, Global Accelerator, and API Gateway. Amazon CloudFront and Global Accelerator are globally distributed by AWS. Amazon CloudFront is CDN, when you can host your static data and cache it on each location. But Global Accelerator use network features, and it makes you to not use public internet, but use AWS global network. And both Amazon CloudFront and Global Accelerator makes us to use failover policy to automatically goes to working environment. Also, we have API Gateway. First of all, is fully serverless service. We can connect it to Lambda and don't manage our infrastructure. Also, it throttles our requests. And if we have a lot of requests, API Gateway will automatically help us to back pressure our network traffic. Yeah, and I think we can provide a solution. Cristian.
Yeah, so a conclusion, we can see that resiliency is very crucial for all modern system and applications. So as you saw at the beginning, even such giants like Google, Meta has a lot of troubles with resiliency. And we also need to have rules and to have services to provide the most resilient solutions as we can. If we prioritize resiliency, we can enhance performance and agility, because when we will have downtime or failover, our system will be back very fast. So we won't have a lot of time down using it. And for testing, we can see that stress test gives us all the information that we need to see how performant is our application, where we can see where is a bottleneck, And also, you can also read about such frameworks like House Monkey that you can use to even simulate failovers. So this is the highest level of resiliency testing, where and if you have a lot of money to test the resiliency and instance, and you will see how it is down, how it is up. So this is all of about this. We can identify risks, and we can prioritize and build a good behavior. And building such system will benefit our stakeholders because they won't have a lot of revenue loss, and our system will have a good reputation, and our data and our processing time won't be lost. So I think that's it.
Thank you for your attention. Let's go to Q&A session.
Thank you, guys. Thank you for this presentation. We have a lot of questions in the chat, but we can start from the hall if we have questions there.
Guys, any questions?
First of all, appreciate your presentation. And one small question. You explained about this new technology, and how often did you use this technology in real project in V9?
I think we use it very much. Even I now moved on the project which based on resiliency update. And one of my goals is to implement, to update project resiliency. And I think this technology, because our application is hosted on AWS, can help me in my real project.
Thank you.
Yes.
Yes.
You mentioned at the beginning about load balance. For this. And I wanted to ask, do you know what strategies AWS have, and if you can choose between different strategies? And I saw in one of your slides about the Elastic strategy.
No, Elastic, it is the name of the load balancer. So we have a
I'm
lot.
sorry, can you repeat the questions because we cannot hear it?
Yes. So for the online users, the question was, what strategies does the load balancer in AWS has? So we have such strategies like cross-zone load balancer. For example, if we have in two availability zone load balancer, we can equally route it from it. For example, if we have in one zone 4 instances and in the second one 6 instances, so the route from all of it will be equally. So this means that every instance will have 10%. If we don't have enabled this cross zone, so you can see that in first, where we have 4, we will have 12.5%, and in the second one, we will have less than 10%. So in this way, you can equally send the requests from a different availability zone. Also about the Elastic Load Balancer, there are 3 types of load balancer that we use. First of all, it is the application load balancer. This is the most common one. It is used on HTTP level, so on the level of requests. So it is very easy to manage, and also it has such features like path routing. So, for example, in the dependency of the path, you can have routing to different services. You can have query params routing. And it works with HTTP and the HTTPS protocols. Also, we have network load balancer, but it is more performant but heavier to implement. It works on TCP level. So we have TCP and TLS level. And third one is gateway, that is the most complex, and it is used for a very heavy and enhanced systems. So most common used load balancer, it is application load balancer, and if you need efficiency and performance, you can use network.
So you mentioned that in this presentation you used FDS for resilience. Is there any options for relational databases in AWS and can be integrated with Lambda?
Okay, repeating the question, can we use some resiliency options for non-relational databases? I think yes, AWS offers us DynamoDB. It's non-relational database. It supports global tables, which can be automatically failover tables. Also, it has a feature of a point-in-time recovery. So if you corrupted or accidentally deleted your data, you can automatically point to a valid source of data.
I also have a question. Actually, in your presentation, you mentioned about a lot of new services, and I'm interested if it's possible somehow efficiently to calculate the cost of infrastructure.
Okay, repeating the question, how can we calculate the cost of our future infrastructure? AWS offers us cloud formation. When you use cloud formation, you can use your infrastructure. It will automatically calculate approximately how much will your infrastructure costs. Also, you can deploy your configuration. You can copy it across regions, which also will increase resiliency of application.
Okay, we have a lot of questions in the chat. So should I read it or you can open it?
Answer last question here.
Okay.
Regions for your infrastructure or just one region?
We now used only one regions, but different availability zones. But you can also perform multi-region deployment, and it will be costly. You need to pay more money. Yeah, it will be more available, but it will be harder to configure and will cost you more money.
Manual steps, like manual steps, or
I think yes. But my multi-AZ automatically will change failover to standby to a failover database. No more questions, or maybe we can go to the chat to read questions.
Yeah, we have a lot of discussions in the chat, but you can check and answer only questions.
Okay, what do you use for a fast and guaranteed DB data migration? As we mentioned, we used multi-AZ deployment. Also, we have RDS backup where we can automate our backups. And if some disaster will happen, we can automatically recover through our disaster from our backup. Can we get the resources link to GitHub? Yeah, I think we will share, not today, but maybe tomorrow. We will prepare it to posting to public GitHub, and we'll share you link.
Yeah, we will share with email. I'll send email to every participant.
So do you use infrastructure? We use, for example, as you saw, Lambda, and also we use EC2. So Lambda, it is the serverless, so it is infrastructure or function as code. And as a strategy, we use trigger from SNS. So Lambda, the main feature of it is that we can attach it to a lot of different services. For example, like SNS or SQS consuming. And attaching it, it will, when the message is receiving, it will trigger it, and it will run the code that we need.
It's a lot of discussions about the cost
Yeah.
of the solution. You can share your thoughts about the cost question of the solution that you discussed.
Yes, so about cost, I think Alexei also told, but you can check it in AWS CloudFormation if you are creating it in this tool with architecture. Also, there is Cost Explorer in AWS and a very interesting tool like cost forecasting. So using the data, it can forecast your future cost for your system. For example, if it can analyze your past month cost, and after that, it will give you the next month cost. Also, there are a very good tool like AWS budgets, where you can put like a limit for your costs. For example, not more than $10 in month. And when this budget is exceeded, you will have an alert and you can manage it and you can see it, what services you can close it and so on. So this is a really useful service as well for costing. Yeah, of course, as the main topic, resiliency cannot be cheap. So yeah, it will be expensive in any way if you want a real resilient system.
I think the next one is about Elastic Cache, yeah?
This one?
The proposed system suggests heavy operations. There is another endpoint for it. Is there a point to use LST cache? I'm not sure how it's read there.
Yeah, Lambda, as Christian mentioned, has some issues. For example, it cannot be run more than 15 minutes and it has some CPU limit. And if we need to, also it, as we showed, the highest amount of time was Lambda used because we need to run it to, yeah, as mentioned that in the chat, it depends on the task. If we can wait and if operation is not taking a lot of time, Lambda is a good point.
Okay, great. Do we have any other questions in the hall? Because I don't see.
So for the stress test, have you had a chance to build a test that will fail and you can see the recovery or how it works? I mean, have you had such an experience?
Yes, so in my project I also used K6 and also had fail. So in our project we have a special alert that we put on SQS. So for us the main bottleneck, as we see, it was message transfer between services, and we put an alert if our threshold is more than it, we are creating a new instance. So I think Alexei can also show you how it looks in console and what are the logs. So in EC2 and auto scaling monitoring, yes, for order, activity, and you can see that here we have SQS messages alarm that was triggered during our testing because we put a very little threshold. But you can put a more realistic one. For example, if you have the enqueue some hundreds for 200-300 of messages that are not consumed in, for example, 1 minute, then you can create an also a new instance. A good feature of auto scaling is that it has three features. So it has the minimum type of count of instances, the desired. For example, what is the desired one that you need? For example, 2, 3, 1, and also the maximum. For example, 10. And when you have a very big load, you can create an alarm, and it will increase the number of these instances till the maximum one. So in this way, you can manage this traffic. You can put, for example, like we show SQS alarm or another, for example, CPU utilization. And for example, CPU percentage of utilization is more than 80%, then you can increase the number of instances.
So does it happen to have some loss in the time when the new instance was created?
No, auto scaling is first of all creating the instance, and after that is deleting the old one. So the prioritize is to manage the number that you need. And after that, later it will delete all the instances.
Okay, one more question in the chat. I think when you have to create a startup, you can try, first of all, for example, to use backup and restore strategy, as I show in beginning, where the RPO and RTO is quite big time, takes hours. And if your startups will become popular, you can switch to a more relevant one.
Okay, thank you. So guys, do you have any other questions? Online, offline? Let's wait 30 seconds. Okay, I think now. So thank you everyone who joined this talk. It was very intense and interesting, and who joined us offline. So pizza and drinks are waiting for you, and also you can discuss. Okay, it's comment. You can discuss all the questions that you have with our speakers during the networking part. So I want to end the online part, and I want to share that we will share the recording of this meetup if you want to share it with your friends or just rewatch it. Thank you everyone and have a nice day. Bye.
Thank you.